In this video, we are going to begin a two-part lesson on piecewise functions. And what we're going to do in this part is we are going to look at reading piecewise functions. So the first one you see in your notes is this one, and I have graphed it for us here on Desmos. And you can see that this is a piecewise function because it is defined in three separate pieces. All right, it's not continuous, and what that means is it's not all connected. You see how I have to jump from here to here, and then I have to jump from here to here, so it's not a continuous graph, but it's called f of x. It is a function. If I put a vertical line across this graph, no matter where I put it, it'll only cross one value at a time. So that means for every x value, there is only one y value. Okay, notice the endpoints here. Look at this one. When x is less than or equal to -5, so less than or equal to, that's got a little equal to line, so I'm going to have a closed-in circle right here. Less than -5 goes to the left. So what this red circle corresponding with this red ray right here, what that's telling me is this part of the function is only valid when x is less than or equal to -5, right? The red part is only right here. Well, as soon as I get to -5, it's going to switch from the red one to the purple one. So the purple one is the line -x plus 10, and it is only valid in between -5 and 2, right? So you can see my x value right here of -5. And then you may not be able to tell, but this is 2. It's a little bit less than halfway in between 0 and 5, so that's 2. And look, this part, I should have an open circle because there's no equal to, and you can see that I do. This part, I should have a closed circle because it is equal to, and you can see that I have that right there. So any value in between -5 and 2, any x value would substitute in here to find the y value that goes with it. All right, now the black one here, that has just 12. And sometimes people think this is confusing. But remember that f of x is the same thing as y, as long as y is a function. And y equals 12, we looked at before as being a horizontal line. So here's my horizontal line, y equals 12. My x value is changing, but my y value is not. It starts when x is greater than 2. So notice that on 2, I have an open circle. All right, notice that the values that are stacked on top of one another are not ever both closed, because then it wouldn't be a function anymore, because the function would exist here and also here. So that's why this one is closed and this one is open, because then the function exists here, but it doesn't actually reach this point at all. So therefore, it remains a function. And the same thing is true here. Now, they could both be open, but they can never both be closed because then it wouldn't be a function anymore. Okay, let's look at this one. Let's see if we can find some specific function values. So this is exactly the same graph and the same equation as what we had on the other page, only this time we're going to read where these particular values are. So look at this first one, f of -8. First thing I have to do is I have to figure out which piece -8 goes with, because remember, for every x, there's only one y. So when x equals -8, what is going to be the y value that goes with it? So is -8 less than or equal to -5? Is it in between -5 and 2? Or is it bigger than 2? Where does -8 fall? Well, -8 is going to come here. -8 is less than or equal to -5, so it's going to be on the red part of the graph. I can only substitute -8 right here, only on this part, right? That's the only place where -8 fits. So I'm going to put -8 in place of x. All right, and then I'm going to simplify that. So according to order of operations, -8 minus 2, that would be -10. Absolute value of -10 is +10. Remember, absolute value measures a distance, so it's always a positive value. 4 times 10 is 40, and 40 plus 1 is 41. So my -8 value would be over here, and if I go up, you can see that it's going to match the positive 41 on my graph. -8, positive 41 would be a point on the graph. Okay, let's do this one, f of 2. Well, this one might be a little bit tricky because I can see 2 in 2 different places. So then the question is, which one actually contains 2? Which one is equal to 2 and which one is not? Well, you can see right here that it's equal to 2. and right here it's not. So the 2 is only going to be on the purple line. So I'm going to take 2 and I'm going to substitute in for x. Negative 2 plus 10 is positive 8. So if you go to 2 on the graph right here, and you can see that particular point is the point 2, 8. All right, how about negative 5? Well, we run into the same issue with negative 5. There's a negative 5 here and a negative 5 here. So which one of these is it equal to? Well, the equal to is here. This one contains negative 5. This one doesn't. So my negative 5 is going to substitute here. So I'm going to put negative 5 in place of x. Okay, now let's see if you guys can evaluate this one on your own. Pause the video and evaluate that. All right, hopefully you got 29. Those absolute value bars, inside of them work sort of like parentheses. You just have to remember that the absolute value is asking a question, and it's asking you how far is negative 7 from 0, which is positive 7. All right, and then to double check, negative 7 would be here. Uh-oh. Oops, I looked at the wrong x value. My x value here is negative 5. Negative 7 is after I simplified. So look at your x value of negative 5, and you can see the y value that goes with it is 29. So the point negative 5, 29 is right there. Okay, let's do 6. Where would 6 fall? Is 6 less than negative 5, in between negative 5 and 2, or greater than 2? Well, 6 is greater than 2. So when f of x, or when 6 is equal to x, what is f of x? What is f of 6? Well, all I have over here is a 12. I don't have any x to substitute my 6 into. All right, remember what this 12 means. It's a horizontal line. Y is always going to be equal to 12, no matter what x is, as long as x is bigger than 2. And 6 is bigger than 2. So this one is just going to be 12. There's nothing to substitute in because it's a horizontal line. There is no x here. All right, same function, only this time I erased my colors. Let's see what we can do with this one. F of negative 4. Okay, which line do you think I should do? Should I substitute into the top line, the middle line, or the bottom line? I hope you picked the the middle line, because negative 4 is in between negative 5 and positive 2. Okay, so let's substitute negative 4 in there. Now be careful. Look, there's a negative on the 4 and there's a negative in the problem. So you're going to have to do negative 4 plus 10. Make sure you get both of those negatives. This negative comes from the problem, and this negative is with the 4. So negative 4, that's going to be positive 4, and 4 plus 10 is equal to 14. Okay, let's look back at our last graph. So when I was at 4, which was right here, 4 is less than, negative 4, sorry, is right here, and you can see that I would be right up here at positive 14. Okay, how about 18? Where does 18 fall? Is it in the top one, in the middle one, or in the bottom one? Well, 18 is bigger than 2, so it's in the bottom one. Okay, so remember, this is the one that just has 12. It doesn't have an x to substitute into, so the y value is just going to be 12. That's our horizontal line where y is 12. All right, next one. How about negative 1? Negative 1 is going to be here in the middle. Negative 1 is in between negative 5 and 12. And I'm going to do the same thing that I did with the 4. Negative 1 will be positive 1 plus 10, which is 11. Okay, so let's go back and check. Negative 1, which is going to be here. And when I look at it, do you see it's just slightly above 10? So that's going to be positive 11. All right, last one, f of 100. Okay, well, I'm not going to be able to see this one on my graph. I didn't go all the way out to 100. So where will 100 fall? Which one of these three? 100 is bigger than 2, So the answer is just going to be 12. There's nothing to substitute in when it's a horizontal line. Okay, so here's a new one. And this one is defined in 4 pieces. So when x is less than or equal to -2, we have this one. You can see the closed circle because of the equal to. When x is in between -2 and -4, not including either one, I have this one, and you can see my absolute value right there. That would be the V shape, open on both ends. When x is in between 4 and 8, including both of them this time, I'm on this line, and that's what I have right here. And when x is greater than 8, open circle on 8, I've got a horizontal line on 15, which is what you see right here. So I've got 4 pieces in this piecewise function. Okay, let's see if we can find the value of these 3. Pause the video and see what you can do. Okay, here's the first set of 3. Double check what you did with that negative in the front. Look right here. You see that I had a negative in the question, and then I also had a negative on the value that I was looking at. My x value is -10. Now remember, order of operations, we have to do exponents before we multiply. So you do not cancel those 2 negatives into a positive. You have to do the exponent. -10 squared is +100, and then make your answer negative. So -100 plus 12, -88. All right, and I did not go far enough on my graph, but you can see that my graph is heading down right here. And if I kept going, I would eventually get to -88 by the time I got to -10. All right, the same thing was true about -2 and -3. Did you notice that -2 substitutes into the first line and not the second line, because this one has an equal to and this one does not? So when I substitute in, remember that negative and negative do not cancel. Order of operations tells me I have to take the exponent first to get +4 and then make it negative. So -2, 8 would be right here. And then -3, 3 is going to be over here. Because that first box goes from 0 to 20, it's maybe a little bit challenging to see that, but you can see that 10, about halfway, would be here. This one is below 10. This one is very close to 0. All right, so there's those first 3 answers. All right, let's see what you guys can do with those 3. See if you can figure out which line each one of them goes into. So I labeled them the top line, bottom, and all the way down to the bottom. See if you can tell me which line I should substitute each of those into. Okay, let's see how you did. 0 is in between -2 and 4, so it should go on line 2. 5 is in between 4 and 8, so it should go on line 3. Now look at that 8. Which line includes 8? This is the one where it's equal, so that one will also be 3. Okay, let's see if you guys can work out those 3 answers. All right, let's see how you guys did. Did you remember to use the absolute value bar sort of like parentheses? So the absolute value of -3 is +3, and then 3 times 3 is 9. On this one, I hope you didn't get mixed up with the fraction. 4/5 times 5. If you look at that, the 5s are going to cancel out, and so you just end up with 4 minus 2, which is equal to 2. Now this last one, make sure you did not put a decimal answer. We want to get in the habit of always putting fraction answers, because most often your computer programs are going to ask for fraction answers, especially if you go to college. Many of the products that they use in college algebra require fraction answers. So let's get in that good habit of making those. Okay, last set. See if you guys can figure out which line each of these goes with. Well, 9, 20, and 25 are all bigger than 8. So all of these, I'm going to look at line number 4. Okay, see if you guys can figure out the y values that go with these. Did you guys remember that when it's a horizontal line, the y value never changes? There's no x to substitute in. So the y value is always going to be 15 if you're on line 4. And you can see that here, right? I would be in this green part right here for all the values that are bigger than 8. And my y value will stay +15 all the time.